Okay, good afternoon, everyone. Sorry. All right. Questions from the homework, which was not to be handed in, as I told you in the email, but for you to do it and ask me questions so we learn the material very well. I have one questions on the board that I will definitely do. Any of you had any other questions, please proceed. And 1F, very good. So we're gonna do number 1. I assume that's section 1.6, and we will do number 3, section 1.6, okay? So let's do that, number 1. And as I'm moving on, I definitely would like you to ask questions. All right, so let's do number 1. And number F. So your classmate asking about number F, but I will do more than that. So it will be very clear. I mean, it's not hard. So we have the following function. It takes an input x, and it associates to it this expression x squared plus 5x plus 6. And the first question is, of course, that's the one I don't think I have to talk about it. What does f do to 4? So it does 2f. Yeah, 1f, 2f, they are, yeah, I'm going to do number 1. Don't worry about that. And so this means it takes me to 4 squared. So I want answers because I don't feel like doing the math in my head. So what is it, f of 4?
42.
How much? 40? I trust you. Okay.
42, sorry.
All right. I will absolutely trust you. We just have to pick up. Now, before I go to part B, I definitely want to connect what we're doing to the graph of the function because it's really crucial. If we take this function and we graph it, it means I take all the point, I sketch all the point where the first coordinate is the input.
That would be y equals mx plus b, right?
What?
That will be y equals mx plus b, right?
No. That's x squared plus 5x plus 6. There is no mx plus b. There is an x squared in here. That's a parabola.
My bad.
That's okay. Don't worry about it. So the first one is the input, and the second one is the output. So if I sit down and sketch all the points, and I get a picture that we can pick it up from our calculator, or later on we'll actually be able to sketch it very easily. It's actually, what did you get the 4 from? From the book. This was problem number A. The question is, what does f do to 4? It takes it to 42. Okay. So graphically, what does this mean? Graphically means the following. This is my 4. According to the graph, and the graph I drew it, and very soon you guys will. This point is the 4 and the 42. Okay, so that's really what we are doing. So we connect what we find to the graph of the function because it's very crucial. All right, now let's look at B, and I will always connect to the graph if possible. So B is asking me, find the output at -3. All right, it means what does the function, the question, Sage, is they give me the function and they tell me find f of 4. It is the input, thanks, yeah. 4 is the input. F of 4, it means if I plug in 4 for x, what do I get? All right, now f of -3. What does this mean? It means if I plug in -3 for x. So this is my function. I will put it again in front of us. X squared plus 5x plus 3. So now the question is, what does the function do to -3? Means whenever we have x, we have to put -3. It takes -3 and square it. It adds to it 5 times -3. Then it adds to it a 6. Okay.
This type of stuff I'm used to. So this type of stuff I'm used to. So I feel very happy about this.
All right, what's the answer here quickly?
Zero.
Yeah, 0.
0. What is it on the graph? It means the function takes -3 to 0. Now it's going to be right here because this is eventually going to be the -2 and this is the -3. Okay, that's really the point we're looking for. It means the function takes the input of -3 to an output of 0. All right, so part C, what does the function do to a half? So a half is somewhere in here, kind of. And the question is, what is the input? So back to the graph here, that's the point I want, because that's what the graph is. Every point where the first coordinate is the input and the second is the output. And here the output is given by this formula right there. So let us compute f of a half. What is f of a half? I just plug in a half here. No, you are not supposed to do this graph. I am doing it so I can connect the problem to the graph because it's important, okay? So it is a half squared plus 5 times a half plus the 6, okay? So I see this equal to 1. Okay. Now we reviewed fraction for a reason because I need to use it all the time. 1/2 squared, it means it's 1/2 squared. Now 5 times a half, it's 5 halves plus 6. And I would like to express this whole problem as one fraction. So I need to find the common denominator. And this is a 2 and this is a 2 squared. So the common denominator is actually 2 squared or 4 if you want. So this will give me 1/4 plus 5 half plus 6. So let
5
us
half
find
is
it.
2.5.
I know that, but I will be asking you to give me your answer as a fraction, not as a decimal.
Oh,
right? And I will be doing this because we want to practice fraction as much as possible. So this will give me 1/4. This will give me 5 times 2 over 2 times 2 because I'm finding a common denominator. 6 times 2, sorry, times 4 over 4 because that's my common denominator. And now I can combine my numerator here. Give me a 1 plus a 10. That's going to give me an 11. And this will give me a 24, which will going to give me 35. Okay, so if I, exactly. So if I ask you, I want the answer as one fraction, which is I will do, it means I want this type of answer. I don't want a decimal. Okay, all right, so it means that on the graph, this output here, this point on the graph is the 35/4. Okay, now a little bit in a more symbolic way, they want us to do the following. F of t plus 2, that's the problem. And that's symbolic now, so we have to do things a bit symbolically because we need them. I mean, so what does it mean? It means every time we have a t, we have to put t plus 2. So this is my input here. So whenever I have an x, I put that. Plus a 5 times the quantity t plus 2, finally plus 6. Now we have to, sorry, I forgot the 2 here. Now we have to simplify. We have to simplify very slowly. The first one is t plus 2 times t plus 2 plus 5 times t plus 2 plus 6. Now we simplify, first we're going to distribute. So I will get t times t plus 2t. And I'm going to distribute this way, 2t plus 2 times 2, it's a 4, plus 5t plus 10 plus 6. Okay. And finally, I will combine like term, giving me t squared. And then I'll have 2t, 4t, 9t. And then I will have 14, 20. Okay, so everybody who got this answer is on the right track. All right, the last two, I know the one you're asking for, but we will do the last two problems. So E is, again,
personal preference next time. Can we not use T as a
no
element?
No way, no way. I have to, because you guys will be encountering this. People will use any name for the variable. Sometimes X, sometimes T. If I'm talking about time, why will I use X for time? Doesn't make sense. I should use T for time. Are you with me? So we have to, otherwise I will not be doing you any service. All right.
Understandable.
What does F do to 2 over Y? Okay, what does it do to any input? Whatever you give it, square it first, whatever you give it, plus 5 times whatever you give it, plus the 6. And now the simplification part. It means I want this to be written as one fraction. So let us see how we're going to do that. The quantity 2 over y squared is what? Remember last time I told you if you have a over b to any power, it's the numerator to the power over the denominator, because it's a times b, a times b, a times b, a times b. So this will give me 2 square over y squared. It's 2 over y times 2 over y. Plus, now we're multiplying. This is, you can think of it as 5 over 1. Multiplying two fractions, multiplying the numerator, which is a 10, over the y, plus a 6. Okay, the last step is a common denominator. Common denominator, in this case, y squared, because it's a multiple of y squared, and it's a multiple of y as well. So y squared is our nice common denominator, and we are basically done. I find a common denominator. I have a y in here, I need y squared, I have to multiply by a y. I have a 6, I need y squared, multiply numerator, denominator by y squared. And now that's the end of the problem. That's a y squared. So it's a little bit of algebra, but I think this is an important algebra for us to do, plus 6 y squared. Okay, so those problems are purely symbolic, but they are important for us. Now, the last one, the one that you are asking me for. Okay, so I will take another sheet of paper and I will do it. Okay, here we are. So my function is always the same. So my function is f of x equal. So that's always, I am not changing the rule. It's x squared plus 5x plus 6. That's the output. That's how the formula is. And the question here is find all the input C, all input C, such that F will take the input C and to 42. Okay? So basically, I go back to the graph. That's why I'm connecting the graph. Now at 4, we got 42, but that's not the only value. So what is now my question? This is 42, right there. And the question is
I forgot about that problem.
Find all the input that give me an output of 42. So this time we have the formula, and our job is, if my output is 42, I want all the input that spits out an output of 42. So how we do that? Okay. We set the equation. Go ahead.
Do we substitute the FOC for 42 and then plug it in for like a other problem?
No, we solve. We solve. What do we solve? We set the output equal to 42, and
that was
we
what I was trying to say.
Yes, yes. If that's what you're trying to say, you're absolutely correct. And then we solve. Is that clear? Mm-hmm. Now let us remember how we solve this type of equation. Okay, now my job is to remind you of that. This is, if you remember a little bit, it's a quadratic, because there is a c square that I need. Usually, not usually, when we have to do quadratic, the way we do it is the following. We try to set it equal to 0 by moving this term to the left. Okay, so I have to move it to the left. And that will give me plus 6 minus 42. Okay, that's always, we have to do it. So this will give me c squared plus 5c. Now 6 minus 42 will give me how much quickly? Anybody? Anyone?
Negative 36.
Negative 36 equal to 0. So the step number 1, when I'm solving a quadratic, to make it equal to 0. Once I hit the stage, remember how do we solve? At this stage, we try to factor out. That's the only way we will solve quadratic. We factored this out and we set equal to 0. So let us remember, how do we factor this out? We look for two numbers. When you multiply them, it's minus 36. And when you add them, somehow it's 5. Which are the candidate for that? Multiply is minus 36. And somehow you add them, you get a 5. What are the two numbers? Quickly, 6, no. When you multiply 6 by minus 1, you get a 6. You want, when you multiply them, I want a 36. So that's one candidate, and then I check. Usually I always double check myself. So let's see if this is going to work. What do I mean if this is going to work? I'm going to distribute, make sure I get the one above it. Let us distribute. C squared minus 4c plus 9c, that's the 5, plus minus 36. So whenever we have a quadratic, and you will encounter a lot of those throughout the semester, at least for now, we always set it equal to 0.
Inner,
and then
outer, or
we try
last.
to factor out. All right? So what does this mean? You have two numbers which are equal to 0. How can this occur? For this to occur, it means one of them has to be equal to 0. So this equation holds if c plus 9 is 0 or c minus 4 equal to 0. The first one will give me c to be negative 9. The second will give me c to be equal to 4. So now we go back and connect it. We knew c equal to 4 will give me 42 because that was the first question in the book. So now we go back and we interpret this graphically. So the scale is not very good, but that's not the point here. It means that this is my 42, and I'm looking for those two input that gave me 42. For one of them, and the other input is minus 9. Okay, so that's how we do those type of problems. Now, number 2, I will be assigning it again for next time because I want to make sure all of you can handle those type of problems. Now, I look at number, which one you guys asked? Number 3. And number 3 is an exercise that's meant for you to practice working with fraction. That's really the goal of this exercise. So let's look at number 3. Okay, I told you to practice the following. You have a function. It takes an input x and spits out the output x over x minus 6. Okay, so that's number 3 in the book. And we have several questions. I will do some of them. So the first question is, they're asking for the output when the input is 4. I don't know why they like 4, but whatever. So I just plug it in. There is nothing deeper than that. 4 over negative 2. I can definitely, this is minus 2. So that's how the function is behaving. All right, I will do f of 1/2 because it's a fraction. And as I told you, I want you to do the problem by keeping the fraction for now, not moving to decimal. What does f do to a half? It's a half here. Down here, it's a half minus 6. As I said, I want this to be simplified. No, so this is equal to. I don't want to go to decimal. We want to practice how we work with fraction. I repeat myself, that's really what I want. I know how to move to decimals. So this is a half right there. Now, I want to write this under the same denominator. What would be the denominator here? Watch, I'm working with the bottom part. The denominator here is going to be common denominator. It's 2. So this will be written a half minus 6 times 2 over 2. Okay, this will give me a half is a half. And down here, I will have common denominator 2 minus 12. Okay, I'm trying to practice every possible rule we know. So finally, I will have a half over minus 11 over 2. Okay, and that's give me what? Property of fractions. Half times the reciprocal of the denominator, which will 2 and 2 simplify, which will give me minus 1 over 11. Did anybody get the same answer? Anyone? Oh, yeah. I don't see anybody. Anybody got minus 1 over 11?
I didn't get minus 1. I got 1 over 11. I don't know what happened.
Ooh, you did not get. All right. Did you understand what I did though?
I believe.
Did you understand what I did?
Yes, I did.
Okay, very good. Now I will do the last problem, F, which is your classmates are asking me about. And I did that like this on purpose so I can do that exactly F following the same principle. So F is symbolic. So they want us a little bit to learn how to work symbolically with functions, because if any of you will have to do calculus, that's what we do over there. So what is f of 3 plus 5? And I will use this verbatim. What does the function do? I'm going to write this function again here because we don't see it clearly. The function takes x, whatever input, to the input over the input minus 6. That's what the action behaves. So this is going to be what? My input here is 3 over y plus 5. So this should be 3 over y plus 5. Over what it does. The input, 3 over y plus 5. It's the input minus 6. That's the setup. Now we need to simplify. This is a mess as an expression. Now, how we are going to simplify this expression? And that's why I spent the time doing this one. Okay. What we're going to do is, okay, the numerator is nice, kind of, it's a fraction. It's the denominator that I would like to simplify it tiny bit. So I want the denominator, this piece, the red one, I want to write it as common denominator. So that's the piece I want to simplify. So this is going to be equal to, I'm not touching the top because it's nice. There is nothing problematic with it. It's this piece that I need to put a common denominator here. So the common denominator here is what? Is
y plus 5?
Is y plus 5. Okay, so everything under the same denominator. So this will give me this piece minus 6 times y plus 5 over y plus 5. I'm trying to, this denominator is just a little bit messy. I want to fix it. So what will this give me now? Equal. Now we know why we find a common denominator. The reason we find it because we can combine numerator. Otherwise we can't. So now I'm still focusing on the bottom part right there. So this will give me very well, that's a y plus 5. And here I will have 3 minus 6 times y plus 5 over 5. Okay, now this is equal to what? We are there, we're there. 3 over y plus 5. And let me a little bit tidy up the denominator. That's a y plus 5 down here. And what will we get in here?
Negative 3y plus 15.
Negative 3y. Negative 3, right? Minus 6y. Minus plus minus 6 times 5, 30. You agree with me?
Oh, yeah, that's right. That's right.
You guys agree with me? I want all of you to make sure. So now let's see how simple our expression is going to become. So one more step, and then we simplify it to something fairly simple. So y plus 5 here, eventually we won't need it. I will have minus 6y minus 30, that will give me minus 27. At this stage, we're there. I have a fraction divided by another one. Nobody like this. I don't, you don't. So now the rule of fraction, this is equal to that times the reciprocal of my denominator. Now we can see that this is the same term. I have the right to simplify it because it's a multiplication, and then I will end up with this expression. Okay, so that's how we simplify expressions. It's a little bit of work at the beginning, but that's all right. Once it's a good practice for you. All right. Very good. Now we're going, I still need to do one algebra review, and I will do it like I did for the fractions. I will review, and I will give you a problem from the book where you have to apply exactly what we're doing. So one more algebra review, and then I stop the algebra review, and we embedded them into the problem. So the review I'm going to do today, and on Brightspace, I put actually a sheet that summarize everything in terms of rules. So today we're going to review the exponent. Very well. All about exponent. Okay, so we start with the very trivial one. First, let us remember the following. Suppose n is a positive integer. Now, what does positive integer mean? It means 1, 2, 3, 4, 5. Okay. A to the n, we all know what it is. So 2 to the power 4 is basically you multiply 2 by itself 4 times. So a to the n, it means you take the number a and you keep multiplying it as many times as n is. Okay, so that's fairly simple. Now, what does it mean? Okay, now if n is 0, a to the 0 is equal to what? I want quickly. A to the 0 is what? What? Any number to the power 0 is equal to 1. Okay, now, so for positive integer, there is nothing really I can say. Now, if n is a negative integer, it means minus 1, minus 2, minus 3. What does it mean to take 2 to a negative 4? What does this mean? Crucial for us. Anybody remember? What's 2? What's a negative exponent? 1, 2 to the negative 4 means, no, not quite. It's 1, we don't change the sign. It's 1 over 2. This is minus 4, positive 4. Okay, which is 1 over 16. So now the definition. My apology. And still a positive integer, my apology. A to minus n means 1 over a to the n. Okay, 1 over, not minus 1 over. It's just 1 over a to the n. So 2 to the minus 4 is 1 over 2 to the 4. Okay, and 3 to the minus 2 means 1 over 3. The power become positive, which is 1 over 9.
Oh, that
Okay.
beautifully makes sense. Thank you.
All right, now let us review the idea of the nth root. So the nth root of a number. Nth root. Okay. First, of course, I start with the one very simple one. So if you have a number a, the square root of a, we know what it is. So the square root is basically a symbol. That's what a symbol. But symbol for what? Is the symbol for the positive number. This is a symbol for the positive number that I can call it a box, just as simple as that, such that has the property. So it's a symbol for the positive number that has the property. What property this positive number has? When you take it and you square it, you get a back. All right, so that's the very simple one, the one that we always work with. So that's the positive number, and this is I, of course, circle it. It's a positive number, I'm gonna call it box, that has the property, when you square it, you get a. So based on that, what's the square root of 4? Is the positive number, so that when you square it, you get 4. And that's the idea. There are two numbers. When you square them, you get 4. There's the +2 and there is the -2. The square root is by definition the positive one. Is that clear? So when I write the square root, it's only positive. That's the definition of the square root. So this is not correct. By definition, the square root, that's the definition, is the positive one, not the negative one.
Because
Right.
you can't really square root a negative.
No, that's not that. That's the definition. That's the definition. The definition is you take the positive number, when you square it, you get 4. That's really the definition. There are two numbers, when you square them, you get 4. You have -2 and you have +2. Both of them give you 4. Which one is the square root of 4? Is the positive one. That's really the definition of it. Now, the cubic root, I will not put any restriction, is the number that has the property, when you cube it, you get the number back. Okay, so with this, yeah, the square root of 4 is 2. So the cubic root of 8 is 2, because when you take 2, raise it to the power 3, you get an 8. Now, cubic root has no issue. I did not say cubic root is the positive number. I didn't put any restriction on it, because there is only one number. When you take to the power 3, you get 8, which is 2, not -2, because -2 to the power 3 will give you a -8. So cubic root of -8, there is no issue with that. This is -2, because -2 to the power 3 equal to -8. Okay, so in general, what is the nth root of a number? The nth
It's
root of a number.
this is basically a reverse version of squaring, because it's square root.
Right. So the nth root, be careful now. The nth root of a is the number that has the property. When you take this number and you raise it to the power n, you get the number a back. So what is the nth root of a? It's the number. When you raise to the power n, you get a. If n is even, like 2, 4, 6, if n is even, we require the number, the box basically, to be positive. That's part of the definition. That's how we define it. So that's the nth root. So let us practice a little bit. So every time I give you something, we practice a tiny bit. So for example, if I ask you what is of course, I have to give you simple problems. What's the fourth root of, okay, 16? That's easy. It means I'm asking you, which number, when you take it to the power 4, you get 16. Now you start thinking, which number? Okay, everybody is telling me 2, and it's the positive one. It's the positive one. It is exactly the plus 2. Now, what is the cubic root? Of course, I have to give you simple numbers. I have no other choice. What's the cubic root of minus 27? Again, which number? You raise it to the power 3, you get minus 27. Anybody? Exactly, that's the minus 3. So that's the nth root of a number. This is going to bring up the other kind of exponent that we call it the fractional exponent. Fractional for fraction, fractional exponent. Okay, what's a fractional exponent? So we define a negative exponent. We define what we mean. We're giving you a definition. I defined what we mean by 3 to the minus 4. The definition is it's a 1 over 3 to the 4. So that's for the negative integers. Now, fractional exponent. What does, you have a number a, what does a to the 1 over n? That's what I mean by fractional. Okay, a to the 1 over n is the nth root of a. Okay, so a to the 1 over n is a way to write the nth root of a. All right, so for example, and that's crucial, and that's important. So if I put 27, if you see something like that to the power a third, what does this mean? So it's nothing more than that's the root, means the cubic root of 27. So it's just not just another way to do that. And the importance of introducing fractional exponent will be to be able to multiply terms. That's what I will do in a second. Okay, so that's exactly why we need them, because to multiply term, we need those fractional exponents. So it's cubic root of 27, big deal. Cubic root of 27 is 3. We've seen it so far. All right, another example. Suppose I give you 16 to the power 1 over 4. Be careful, the denominator is the root. That's really the root, always. This is nothing more than the 4th root of 16, okay? And we just a minute ago, we said it's 2 because 2 to the power 4 is equal to 60. So that's what the fractional exponent is. Now, there is another one, okay, still fractional exponent, which is the following. And again, we have to define it. It goes like that. So, what if you have, so that's the last definition for exponent. A to the power m over n. Real fraction this time, m over n. So what does this mean? This means that n always stands for the root, means the nth root for a, and m, it means to the power m. Okay, so that's the hardest one of all. And this is basically the same thing. So that's the same as you can take a to the power m and the nth power of that. So in the expression a to the m over n, the denominator is the root, the nth root. This one is the exponent, if you want, the power. So immediately we practice this notation. All right, so for example, I will ask you to evaluate 64 to the power 3/2. Okay, I know it's hard at the beginning. I mean, some of you, of course, have seen this stuff. So this is equal to what? Which is the root and which is the power? The denominator is the root. It means since it's 2, That's the same thing as the square root. So that's the square root of 64. Usually we don't write the 2. The whole thing raised to the power 3. Now we know it. The square root of 64 is 8, right? To the power 3. And I don't know how much this is. I think 192. Trust me on that. Okay? 512. Thanks. I trust you guys. Okay? Let's take another one. Let's take another one. Suppose I take 64. It's the same number. But this time I take it to the power 2/3. Is it a very different one? Is it a very different than before? What's the root here? It's the denominator. So this means that we're going to take the cubic root, that's the root, of the number and raise the whole thing to the power 2. All right, so we have to be very careful. Now I'm having 16. I think you guys are right. Let me check. Cubic root of 64. Which number, when you raise it to the power 3, is 64? Now, since I'm 4 square, that's 4. So the cubic root of 64 is 4 square, which is give me 16. Okay. Now, one more, and then we talk about the property of the exponent. So one more is the following. I'm going to combine two things. Suppose I give you 4 to the minus a half. So now I'm combining two ideas. So I have fraction and I have a negative. The negative tells me that you take 1/4 to the half. Now 4 to the half, the root is 2, is the square root of 4, which is a half. So this time I put the minus to combine both ideas. And finally, the last one. Let us say I give you 27 to the minus 2/3. Again, there are two things. There is a fraction and there is a negative. I first take care of the negative because we understand things when 1/4. 27 to the power 2/3. Once I take care of the negative, I ask myself, okay, what does this mean? 3, it means you're taking the square root, the cubic root of 27. 2 tells me you raise the whole thing to the power 2. And now my answer is relatively simple. Cubic root of 27, the number when you take to power 3, 27 is 3, because 3 to the power 3, 3 times 3, 9, times 3 is 27. And the whole thing, we square it, giving rise to 1/9. Okay, so that's the fractional exponent, very important for us to get. Now, I review again slowly with you the rule, the law of exponent. So I'm gonna start reviewing the law of exponent as much as we can today, and Tuesday we finalize this review, hopefully. Okay, the law of exponent. What do I mean by the law of exponent? So now we know what the power mean, what the exponent mean. Now we're going to study the law. Okay, a lot of them you've seen, we review it. So suppose I have one base A, and I have a to the n, you multiply it. So that's crucial, a to the m. Now I want to combine those. This is gonna give me a to which power? And let's see. Before we give the answer, let us see what I'm talking about. Very simple. Suppose I take 2 square and multiply it by 2 to the power 5. As simple as that. How many 2's do I have? 2 2's from here. And how many of here I have? 5. So how many 2's altogether I'm going to have?
7.
2 plus 5. I'm going to add them to each other. Okay, so try to make sense out of it so you will not forget them. Because here I have 2 of them, and here I have 5 of them. 5 of them. So how many I have altogether? 2 plus 5. So this is 2 to the power 2 plus 5. All right, so this gives me that this is n plus m. Okay, ever forget? Go back to simple example, and this will help you to remember all those laws that we need, pure and simple. Now, if I take a n and I raise it to a power n, that's a very different problem now, very different than before. What does this mean? Let's go back to the problem here. If I take 2 square, and this 2 square, I raise it to the power 5. So now how many 2's do I have? I have 2 square, 2 square, 2 square, 2 square, 2 square, right? 1, 2, 3. So how many 2's do I have? 1, 2, 3, 4, 5 2's. So it means which power I'm going to have here? Quickly.
I said 10.
We have 10. Where is the 10 coming from? 2 times the 5. I have 5 2's. So this is a to the n times m. Crucial. Those properties are very essential. All right. Now the other properties. If you take 2 numbers, a and b, and you multiply them, this is a product. It's crucial. And, oh, sorry, guys. Okay, my apology. All right, ab to the power n. This is equal to what? Okay, we're gonna a little bit split it. Again, if I take ab to the power 3, what does it mean? ab times ab times ab. So how many a's do I have? 1, 2, 3. A to the 3 times b to the 3. So this is a to the n times b to the n. Okay. Now the other property which work the same. If I have a over b to the n, I will have a n over b to the n. Okay. And the other property of the law, of the exponent that we need, 2 more, simple. I have a n divided by that. Say to which power? Okay, let's take example. If I have 2 to the 7 and I divide it by, let us say 2 square, what should I get? 2 to the 7, it means I have 7 2's. 1, 2, 3, 4, 5, 6, 7.
So it's the
To
first
square it
exponent
means I
divided by
have
the
2
second
2's.
exponent.
So those 2 2's will simplify, and I'm left with 5 of them. It means 7 minus the 2. So this is going to give me the n minus m. Okay, so go over those little examples I'm giving you to make sense out of those properties. So these are the basic properties, but there is 2 also I would like even to write clearly because we need them. You need them. If I have a product here, I can split this. As long as I have a product, I can split it. And the last one also, because it helps us work with the root, a over b, I can split it this way, over that, okay? So these are the main properties of the exponent. I will do 2 problems because I have a worksheet for you for Tuesday, not for grade, not to be collected, but for you to practice what I am doing. I think that very clear. So I'm going to do 2 exercises to give you an idea. What am I expecting you to be able to do? So here is my problem. The question is going to be fill in the box, pure and simple. So I'm going to give you a box, and my question is fill in the box. And the idea is to use the properties to be able to do them. Okay, so let me take the first problem. Suppose I tell you the first simple one. cubic root of x. This is my box. My question is, what should go in the box? Quickly, I want answer on chat. That's my question. So what should go into the box? That's the kind of, no, be very careful. No, it's 1/3. Because x cubed is x times x times x. That's not the cubic root of x. The cubic root of x is x to the power 1/3. That's how I'm expecting you to practice those problems. All right, I will give another one. Let us say I give you, I don't know, make it a bit 1 over the cubic root of x. How will this be affected? What do you think is going to be the power? So my question is x to which power? That's what I am after. Minus 1/3. Do you agree with Connor? Okay, let's see. Let's make sense out of what Connor's saying. This is me 1 over x to the power 1/3. Now, 1 over x, it means x to the minus 1/3. So the box I'm after is minus 1/3. Right? In other problems, I mean, I have tons of them, especially for your homework. Problem number 2. Suppose I give you the following. It's simple. X squared times x6. My question is, what should go in the box? And here I'm always expecting you to use the law of exponent clearly.
In this case, that'll be 8.
That would be 8. If you ever forget, remember what I did in class to convince you of that. So we add them. So add them. Okay. Now let's make it a little bit harder. So suppose I'm going to take x and I'm going to multiply it by the cubic root of x. Now, even though I showed you the law of exponent for simple integers, but those laws apply even if our exponent are negative or fractional exponent. So now my question is, this is x to which power I am after the box. So how do we handle something like that? And that's really why fractional exponent will be important. Absolutely correct, Kayla. All of you are doing it correctly. So let me do it slowly. You guys are fine. This is x, but to which power? The cubic root is to the power 1/3. Okay, now, what are the law of exponent? I have the same base x. I have a multiplication. So the law of exponent tells me you add the power 1 plus 1/3. This is a fraction, big deal. What is 1 plus 1/3? So we can go to the side and do it. Common denominator is 3. This would give me 4/3. So that's x to the 4/3. So what goes in the box is nothing more than 4/3. Okay, so that's really the kind of problem I'm expecting you to be able to do for Tuesday, not to hand it in, not for grade, for practice. And I will go over them with you. Is that very clear? So, all right. One more, and then we take the quiz. I want the following. I'm going to give you the expression minus 8 x y to the power 6. And my question to you now is, I want you to rewrite this as a box, x to another one, and y to another one. Not the same value. Those don't have the same value. So how can I simplify this expression? Basically, that's what I want. All right, I will do that quickly because we need to take the quiz. So if I'm faced with this problem, what will I do? Okay. One of the law I told you about is that if you're finding the nth root of something, and if you have a multiplication product, you can split the product. This is beneficial. So here, sorry, I want the cubic root, my apology. Okay. Here I'm multiplying this by that. The law of exponent tell me, you know, you can split this into that times this times that. Okay, it makes things simpler, very simpler for us to work with. Now, each one by itself I will treat. What's the cubic root of minus 8 minus 2? I took care of the first term. What's the cubic root of x? If I want to write this using those exponents, as I said a minute ago, that's x to the power a third. Very good. Finally, what's this? So that's y6, because that's y6, and cubic root. Now, of course, a lot of you can know the answer, but I'm doing it slowly for the time being. So finally, I don't really like this. It's silly messed up. This is messy for me. I don't really like that. So let me fix it. It's minus 2 x to the power a third times y to which power now? Y to which power? Y squared. Kayla is telling me y squared. Is Kayla correct? Okay, let us remember, if you have a n to the power m, you multiply the power. 6 times a third, 6 times a third, it's equal to 2y squared. Okay, that's how it's different. So for Tuesday, please, not to hand it in, not for grade, but that's not why you should do the work. You should do the work to learn, okay? Till I figure out exactly how we're gonna do handing in the homework. But now I'm very clear. For Tuesday, there is a worksheet. I'm gonna put a worksheet on Brightspace, which is along those lines. And even Moodle does not have those type of problems that I really want you to learn. Please do it, not for grade again. You do it, and then on Tuesday we discuss those problems so you know exactly how to do them. All right, any questions before I go before we start the quiz?
Oh, we're starting quiz now? Okay, never mind then.
Beg your pardon, repeat your question, please.
It's nothing.
Thank you very much. Okay, anybody has any questions before we take the quiz?
How much time will you normally give us to take the quizzes?
I'm giving you like almost half an hour, even though you only need 10 minutes for it. But I'm just giving you a lot of times. All right. So if you start to write now, you guys should be done. It should not take more
How
than.
are we turning it in?
What? I'm closing it.
How are we?
I'm closing it at 2:30.
She's asking how you turn it in. I think what she's trying to say is that you're going to be getting the quiz on Brightspace, and then after you complete it, you submit the form to Brightspace.
Yes, that last time, exactly. You guys did very well last time. All of you submitted to Brightspace properly. All right? Any other questions? So let me share the screen with you to remind you how you do it. So I'm going to share the screen just to remind you how we do that. So you go to Brightspace. You go back to, okay, I have to be in your site. So this is view as learner, as usual. You go to content, right? Okay, that's already done. That's the quiz 1, we're done. That's the quiz 2. Click on quiz. Click on quiz, and you start taking it. Okay, I wanted it written on a nice sheet of paper, very clear, everything numbers. The quiz should not take more than 15 minutes. I'm just giving you extra time. When you're done, you upload it into Brightspace and you hit submit. Any questions before I mute? And if you have any questions, as usual, please use chat, only chat. Okay? So I need to stop sharing the screen. I hope all of you have it by now, because otherwise I can't read your chat. Is the quiz locked?
Yeah, mine's open.
Yeah, it should be open. I opened it. Anybody else have problem? I can't click quiz 2. Please, it's quiz 2, not quiz 1. Okay? Anybody still having issue? Thanks, Kathleen. Yeah, you have the time zone is the time zone here in the Calumet area.